Wanted to generate a LED fading effect for my upcoming video tutorial using the 555 timer IC. I already have a video where I used LM358 dual operational amplifier IC and another one with Arduino to generate the LED fading effect. YouTube is full of videos showing how to generate the fading effect using the 555 timer IC. However, none of them produce a true fading effect. Some just fades in but never fades out. And there is literally no explanation of how they are generating the fading effect other than just showing how to assemble the components. In this tutorial, I'm going to show you guys how to create a true LED fading effect using the 555 timer IC. I will also explain how the circuit works and how changing component changes the fading effect of the LEDs.
This video is sponsored by PCBWay. PCBWay specializes in manufacturing of very high quality, low volume, colored PCBs at a very budgetary price. In addition to standard PCBs, you can order advanced PCBs, aluminum PCBs, rigid flex PCBs. They also provide PCB assembly and other related services which can meet your need at the greatest extent.
For this tutorial, you need one 555 timer IC, one 47 kilo ohm resistor, one 220 ohm resistor, one BC548 NPN transistor, one 33 microfarad capacitor, and few blue LEDs. The heart of this circuit is the 555 timer IC. Pin number 1 of the IC is connected to ground. By connecting pin number 2 and 6 of the 555 timer IC, we put the IC in astable mode. In astable mode, the 555 timer IC acts as an oscillator, re-triggering itself, generating square waves from output pin number 3. Three other components connect to this junction. First one is the 33 microfarad capacitor. The positive pin of the capacitor connects to this junction and the negative pin is grounded. Second one is the 47 kilo ohm resistor. One of its legs connects to this junction and the other leg is connected to the output pin number 3 of the IC. Third one is the base of the BC548 NPN transistor. The collector of the transistor along with pin number 8 and 4 of the IC connects to the positive terminal of the battery. The LED along with its current limiting resistor is connected to the emitter of the transistor. That's it. As simple as that. Alright, now I am going to demonstrate how this circuit works with the help of an animation. When pin number 2 of the IC detects voltage less than 1/3 of the supply voltage, it turns on the output on pin number 3. And when pin number 6 detects voltage more than 2/3 of the supply voltage, it turns off the output. This is how the trigger pin number 2 and the threshold pin number 6 of the 555 timer IC senses voltage and controls the output at pin number 3. The capacitor attached to the circuit will be in discharge state immediately after firing up the circuit. So the voltage at pin number 2 will be 0 volts, which is less than 1/3 of the supply voltage. This will turn on the output on pin number 3. Since pin number 3 is looped back to pin number 2, it will start charging the capacitor via the 47 kilo ohm resistor. At the same time, the base current of the transistor will also increase, causing the LED to slowly fade in. Once the voltage across the capacitor crosses 2/3 of the supply voltage, pin number 6 turns off the output. This causes the capacitor to slowly discharge, causing the base current to fall, and hence the LED starts fading out. Once the voltage across the capacitor falls below 1/3 of the supply voltage, pin number 2 turns on the output and the above cycle continues. You can hook up a multimeter to the circuit to measure the charging and discharging of the capacitor. So here is a quick demo on a breadboard. In the current setup, I have a 33 microfarad capacitor and a blue LED on the breadboard. Replacing the 33 microfarad capacitor with a 100 microfarad capacitor makes the LED fade in and out slower as the 100 microfarad capacitor charges and discharges slower than the 33 microfarad capacitor. Also, by replacing the blue LED with a red LED, we can make the LED to stay on longer than the blue one with the same value of capacitor. This is because the forward voltage of the blue LED is higher than that of the red LED. Forward voltage is the minimum amount of voltage that is required to allow an electrical component to turn on. The red, green and yellow LEDs have relatively low forward voltage ranging from 1.6 to 2.2 volts and hence stay on longer when the capacitor slowly charges or discharges. However, blue and white LEDs start conducting from 2.5 to 4 volts and hence when the discharging capacitor voltage hits the threshold, the LED turns off faster than the other colors. I have provided a link of how the forward voltage works in the description below. If you connect few LEDs in series, the forward voltage adds up and hence it will require more voltage to turn on the LEDs. You need to add a current limiting resistor between the emitter of the transistor and the LED to avoid an internal short circuit inside the LED. To make it easy for you guys, I have created this tiny little 555 LED fader module. After assembling the components, you just need to power this module by providing a voltage between 5 volt to 15 volts to fade the LED. So this is how my board looks like in 2D and 3D. There are 16 breakout boards in this 100 cm by 100 cm assembly. You can download the Gerber file from the link provided in the description below and order it from PCBWay. Let me quickly show you guys how to assemble the components to this custom made board. Let's start by soldering the IC base to the board. Then let's solder the two resistors to the board. Next, let's solder the capacitor followed by the transistor to the board. Then let's solder the LED socket and power socket to the board. You can either solder a pair of female pin header or male pin header or solder a pair of wires directly to the board to power this module. Once done, let's insert the 555 timer IC to the IC base. Cool, so this is how the module finally looks like. You can install female pin headers in place of the LED or capacitor if you want to use this as a development or testing board instead of a module. Thanks again for watching this video. I hope it helps you. If you want to support me, you can subscribe to my channel and watch my other videos. Thanks. See you again in my next video. Bye now.